I'm going to give you an example now of a sum of a geometric series that's an infinite series. Notice the 3 dots. 4 dots means it goes on forever. There's no last term. So, how do you find this sum? Well, notice I have a third formula here. When we did the other formula, I forgot to note that in this formula, r cannot equal 1. Hopefully you realize that, because when 1 is in the bottom, you get a 0, which makes the whole fraction undefined. All right, so the sum of an infinite geometric series is the first term over 1 minus r. One technicality, the absolute value of r has to be less than 1, or r has to be a fraction or a decimal number, but not a whole number. All right, or a number larger than 1, I guess, or equal to 1. Because again, equal to 1 gives us 0 in the bottom also. So, what do I need to find? I need the first term. Do you know what it is? Yeah, 64. All right, I need the r. Remember how to find the r? 64 times r equals 48. And just use your trusty old calculator to solve for r. So r is 48 over 64. Of course, you can reduce that and you get 3/4. So r is 3/4. So r, 3/4. Now, let's plug it into the formula. So 64 over 1 minus 3/4. 64 over 1/4, which, so that's 256. So the sum of that series, all right, is 256. Okay, I got 2 more examples I want to do for you. All right, here's another series. I want to find the sum. I'm going to use this. So first of all, I want to find the r. How do I find the r? 80 times r equals negative 40. r equals negative 40 over 80, which is negative 1/2. All right, now check, is the r less than 1? Yeah, absolute value of r is less than 1. So this series does have a sum, so what's the formula? a1 over 1 minus the r, which is 1/2. So it's 81 over 1 plus 1/2. 81 over 3/2, which is using... Okay, so I have 3 examples to do the sum of an infinite geometric series. And so here we go. Let's first define the parts. Here's the formula for sum of an infinite series. It's the first term over 1 minus r. One technical difficulty, r has to be less than 1. Absolute value of r has to be less than 1. Or r needs to be a fraction. All right, first thing we need to do is find the parts. Do I know a1? Yeah, it's 80. Do I know r? I can find it. 80 times r equals negative 40. r equals negative 40 over 80. How about negative 1/2? Okay, negative 1/2. All right, let's go to using the formula. So the sum of this infinite series is 80, which is a1, over 1 minus the r, which is negative 1/2. So that's 80 over 3/2, right? So what's 80 divided by 3/2? Use your calculator, and you get 160 over 3. That's the sum of this geometric series. What about this one? Let's find the sum here. What's the first term? A sub 1 equals 6, right? What's the r? Oh, gotta find it again. So 6 times r equals negative 6 root 3. Divide by 6. r equals negative root 3. All right, is the absolute of r less than 1? Root 3, what is that? Check it out on the calculator. Root 3, 1 point something. So bigger than 1. So, no sum. All right? Let's try one more. Oh, this one is given to me in different notation. I need to write out the series so I can find the r first. So let's find the first few terms of this series. So if n is 1, it's 4 times 10 to the negative 1. that's 4 over 10 to the 1. So 4 over 10. There's that first term. Let's find the second term. That would be 4 times 10 to the negative 2, or 4 over 10 squared, 4 over 100. What's the third term? 4 times 10 to the negative 3, 4 over 1,000. All right, so now I have 3 of the terms. 4 over 10 plus 4 over 100 plus 4 over 1,000, and so on. Can I find the r? Yeah, 4 over 10 times r equals 4 over 100. Sorry about that. 4 over 100. Let's fix that so you can read it. 4 over 100. There we go. All right, solve for r. So divide by 4 over 10. Or multiply by 10 over 4. What do I get? R equals 1/10. All right, check it out. Is that r less than 1? It sure is. So the sum is the first term, which is 4/10, all over 1 minus the r, which is 1/10. So 4/10 over 9/10. You can use your calculator, or maybe you know that's 4 over 9. You can do it quickly in your head. You good? All right. Good luck.